Hey guys, welcome back to another episode of the Real Hacker Hours podcast. Today I'm going to be working on a new tool, effectively a static bug finder written in the Ghidra API. Now, I know a few months ago I was kind of running a similar tool using SemGrep. What happened with that is since then SemGrep has launched some updates that basically broke all my rules. So instead of dealing with that and any potential new updates that will break the functionality that I have, I've just decided to write it using Ghidra's API. Now, kind of what this tool will effectively do is we will define certain functions that we want to be, what's the right term, analyzed, and we'll go through, find the references to it, and then launch various functions like analyze gets, which will analyze all of the gets references, analyze read, which will analyze all of the read references. And how I'm designing this tool is, since for a lot of the functions, like for instance fgets, memcopy, and read, effectively I'm applying the same checks to all of them. What I'm going to be doing is I'm going to be writing kind of like these abstract function checks that I can then just call here. Like for read, I'm going to have read static check, which this probably won't find too much outside of CTF challenges. It effectively just checks to see, is the read call, is it scanning in a constant amount into a fixed size buffer, and if so, just do a quick size comparison. Read variable write stack check, that checks if it is writing in a variable amount of data into a fixed size stack buffer. Also, I'm going to have read variable write check. This is just checking to see if it is scanning in a variable amount of data, and I'm going to copy these arguments. Now, what these arguments mean, function to analyze, that's just the function that we're looking at for. So for analyze read, it's the read function. For analyze gets, it's the gets function. Ref, that is the reference in Ghidra as to where the exact function is being called. These last two arguments, effectively what they are, is they specify the destination and the size. Argument, like where the index goes, for instance for read. The size is the last argument and the destination is the second. For fgets, the destination is the first and the size is the second. And I believe there was one more check I had configured for read. Variable write stack check, variable write check, read static check. Nope, that's it. Okay, cool. Now, what I have done is, let me open up. I've written some basic POC, well, some basic test cases just to do some basic proof of concepts that these checks are actually working. Let's take a look at those. So for read 000, let's look at the source code. What is that? Okay, it's scanning in a constant size into a fixed size buffer, stack overflow, classic one that we've seen there. One thing that just occurred to me that I didn't do with the checks is what I'm doing, what I plan on doing is when the check actually flags something, it will call the report function, and this will actually log the, what's the right term here, flagged check into some fashion. Currently I just have it being printed out here, but I should probably go ahead and just actually implement this function into the checks. So for read static check, let's go ahead and do that. What are the arguments for this report? I'm just going to copy this over to this screen right here just for a reference. First argument is the flagged function, so that will be the function to analyze. Second is the reference. Third is the string, which is just the real type being flagged. Might be better to make this, yeah, I'm pretty sure it would be better to make this just like a constant integer enum. Reason for that being is I wouldn't have to have 20 different strings and worry about them all being the same thing. That would probably just make things simpler. So I think it's been a while since I've written Ghidra. I forget if I can do this, but I'm just gonna Google like what the proper way is to make a constant integer in Java. Okay, I'm just going to make a private static int read static check equals 0. So we're just going to pass this as the enum here, and I'm going to change the function definition to an integer. Okay, cool. So, and also in the report out. Oh yeah, the report function probably have like a switch statement for the check type that's like if it is read static check, put this string with the flag check, or mark this, or like store this checked flag result with all of the check results for the same type, something like that. So we have that function set up. Actually, let me just make sure this is in the right area. No, it is not. I just realized that this is in the wrong spot. So what we can do, so let me explain how this check works, like the real quick the code. This one right here gets the calling function where the reference is happening. So like let's say if get is being called in the main function, it'll get us main. This decompiles the function that is being called, so in the example I just listed to be decompiling main. This right here gets the P codes associated with the call site of where the function is happening. What are P codes? P codes are intermediate language. What is an intermediate language or an IL? When you're compiling code from, let's say, C to assembly or vice versa, you typically don't go straight from one to the other. You compile it into various other intermediate languages. P codes is the IL that Ghidra uses, and this function will get us the P codes associated with the call site, which will allow us to look at it. So we iterate through it. We just check the first to see, hey, is this a P code? Is a call, which is the one that we're interested in. Since multiple P codes can be associated with a single address, then what we do is for a call P code, the first argument is typically the address being called. So we just take a look at that first argument and see if it is indeed an address. Which for that we just grab the var nodes of the P code, since P codes take var nodes as arguments. Don't need that. Actually, what I can do is I can go ahead and show it. Yeah, okay, that check is working. Also, how you leverage or actually use Ghidra's headless APIs with the headless analyzer, which, wait, what is happening here? No pointer. Okay. What is this issue? It's saying class not found. Okay, this is looking like a fun issue. It's not giving me any error. I can clearly see Java language not found, and then it's giving me some errors from the actual headless analyzer. It doesn't look like it's from my script. I'm gonna just try commenting these out real quick, because the last change I made was like uncommenting and adding those, and it was working before that, so maybe not the issue. Let's try running it with a different binary. Maybe it's an issue with the binary. I'm not really too sure here. Nope. What I just did was I removed the command line argument for actually running my script, just to see if it worked just fine, and it did, so it's an issue with my script. What could be the issue? It could actually read static check. What? Don't think it'd be that, but yeah, it's probably definitely not that. What is the issue here? Phalanx headless analyzer. Java language class not found. Well, if you think about it, and oh, it's probably that. Yeah, I typed integer as int, not the full integer, and that is not the problem. 5, what's... What could be the issue? I'm going to try a different Ghidra project here. By the way, the syntax for a headless analyzer: first we specify that you want to run it, directory to the Ghidra project, name of the Ghidra project, and then either tag process if you're dealing with a binary that's already imported into the project, or tag import if it's a new one. This is, I believe, going to create a new project, so we can do import, and then tag postscript. This is a script that you want to run after you are done doing your analysis. Nope, that did not fix the problem at all. What is the issue here? Phalanx. Oh, I'm going to try doing this. How many changes do I remember? Okay, I definitely just messed up some stuff. I'm going to pause it for a second. Okay, so yeah, I just hit Control Z, so I did a bunch of stuff, and it is now running properly, as you see here. So it was an issue with something I did, but what I'm going to try and do now is just quickly redo the checks. Actually, this will be a good opportunity. I'll just quickly rewrite this check and explain exactly what's going on here. Read variable right stack check. This is just checking to see if it is, if it is doing a variable sized write into a fixed size stack buffer. This will be very similar to read static check. Oh, okay, that's the other. I knew there was a fourth check that I was thinking of but forgetting. Actually, it's going to be the combination of read static check and read variable write check. Read static check, this effectively just checks to see if... Read static check. Oh, wait, yeah, no. That does what I just described. Okay, yeah, read static check is the one that does the constant size check against the fixed size stack buffer. I'm just scrambled brain tonight. Let's finish. Actually, let me think for a second how I want to do this. Okay, cool. So right now, looking at, I want to finish read static check, and it's almost done. I just need to add the report functionality. So how I described to you, this stuff is basically getting the P codes associated with the call sign. This one's checking to see, iterating through all of the P codes associated with that reference. This one checks to see, make sure that it's a call. First var node is the address. Here it is checking to see if the address being called is indeed the function that we're looking at, and it does this by getting the offset associated with the var node and the offset, that's basically the address of the function just being called, and it's just checking to see if it is actually equal to the function that we are looking at. Here we get the var node associated with the destination and the size. Get var, should probably name this to, I'm going to rename this function real quick because that's not a good name for it. Stack var size. Get stack var size, this function is responsible for checking, first off, checking to see if a var node that we pass it does model a stack variable, and if so, give us the size of it, or roughly, be better to say the offset to the return address. How does it do this? It first checks to see the P code where the var node is defined, and then it'll just check to see, is there an offset associated with that that is negative? Why negative? Because Ghidra, like how it addresses stack variables, is RBP minus whatever value. Yeah, because how like the stack typically works is there's a base pointer and the stack pointer and the base pointer, and a lot of variables are referenced by like base pointer minus some offset. That's why it models it based off of that. So what am I doing here? I'm just checking to see, is the offset negative, and if it is, it's a stack variable and we can return that offset. However, if it's positive, it's probably enum for a register. So what I'll need to do for here is, actually, let's rename this to stack offset because that's a bit more appropriate. If stack offset is greater than or equal to 0, return. We can just straight up return instead of continuing, since if we get to this point we're looking at the P code that is actually responsible for the call. Next up, there's the size. Oh wait, no. I just realized this isn't right. Reason for it being, get stack var size. What it will do is it will return the absolute value of the offset, and since offset's negative, it'll give us a positive value. What it will do is will return a -1 in the event that it doesn't find a stack sized buffer. So what I can do is instead, if it is equal to -1, then return, then we get the size, and then we can do a check. If size is greater than stack less than or equal to stack offset, return. This is just checking to see, yeah, is the size less than or equal to the size of the buffer, and if so, return. Meaning that if we get past here, the check has indeed flagged a buffer overflow. So what we can do is we can just go ahead and write the report here, report function. Actually, first I'm gonna just run it to make sure it didn't do anything smooth brain that wrecked the code that is indeed still functioning. Read variable right stack check line. Oh, this prototype isn't finished. Okay. Let's rewrite it, or rerun it, I should say. Okay, that worked just fine. Let's do the report function. Now, since I undid a bunch of stuff, this is a string. It should be an integer. Let's check where is report called. Actually, that might be it right there. The issue that we had. Private string, not string. Final integer. Call check equals 0. Private static final integer. Read static check. Call check and read static check. Let's go substitute in these enums. Now, what the call check effectively does is just checks if a function is called. This is primarily for the gets function, since whenever it is called, that is a, what do you call it, a bug. And then for the, what was the other function? This one right here, we can go ahead and write the report for it. Function to analyze the reference and the read static check. Let's go ahead and run it and make sure that works just fine. Okay, that works just fine. Next, let's just quickly rewrite the read variable or rate stack check. Actually, no, let's first. Actually, let me think. How do I want to do this for a second? Yeah, I want to. Before I do that, let's write the function for read variable write check. Since effectively the read variable rate stack check is just like frankly an extension of that check from the perspective of like what the code does, I think it'd make more sense to write this check first. Now for this, later off I'm gonna just copy and paste this code real quickly. When I write a few more checks and I get like a better idea, so like what I'll exactly need from the checks, I'll probably like offload the majority of this to helper functions. That way, I don't have the same like blocks of code everywhere. But for now, this is what I'm doing. As next. This code right here effectively does the same thing of just getting us to the P code that we actually want to look at. So, okay, we've reached there. This is read variable write check. Actually, I also forgot the arguments for this. So let's go ahead and just write those. Func to analyze, reference ref, int size arg. Okay, cool. I just realized I'm using int and integer interchangeably. Should probably fix that. Now, for this, I'm only looking at the size of the write being done. I'm not. This check doesn't at all look at the destination. So I only need that var node dest equals inputs plus 1. Also, I'm just going to go ahead and just quickly show you what P code and what the var nodes look like. Let's go ahead and run the script. Okay. Let's see if I made any other typos in my code. Yes, I did. Misspelled function. Okay, this works. Okay, cool. This right here is what one of the Ghidra P codes looks like. This is a call P code, so it's call. This first for our node is the address being called and the rest are the arguments. This being the destination, this being the size, and this being the source. Okay, and cool. So for this one, the read variable right check, we're only looking at the size of our node, which is this. We can get it doing by this right here. We're just parse out the size for our node. And then after that, I believe the var node has a function called isConstant. So you can just do a check, actually f constant return. Just going to go ahead and run this just to make sure that it works just fine. Forgot a semicolon, of course. Okay, this is working just fine. Let's go ahead and write the report. So func to analyze ref and read variable right check. And I'm going to go ahead and make the constant for this. Private static final integer equals 2. Okay, and what was, okay, so read 000 is just a static constant size into a static buffer. What was read 001? Static size, which one is dynamic? Okay, this one, the size is a variable. You can tell that because it's, at least from the perspective of looking at it from the binary, because the size argument is passed in as an argument to the function, so it has to be a variable. So what we can do is I'm going to run it against read 002 and see if it prints out that the check has been flagged. Read 2. Actually, looking at the report function, we can see it effectively just prints flagged. Flagged function read. The reference and the check type, we can see it printed out too. Which, looking at here, we can see, yeah, that's the enum we specified. And we run against read 001. It should not print out 2. Okay, it printed out 2, but it wasn't part of the flagged. Yeah, it wasn't part of this report function. We can tell that because flagged wasn't printed out. So that worked just fine. However, I'm going to go ahead and get rid of some of the excess print I have throughout this function, or not this code base, just to make our lives a little bit easier. We don't need these. Read static. Don't need this. We don't need this. Print all methods. Oh, I remember. Yeah, we don't need that function. I remember why I had that. Analyzing. Don't need that. Don't need this. Okay, and this is just a sanity check. So cool. Yeah, this time since we got rid of the excess prints, it should not print too. Okay, cool. Also, I'm gonna do a quick, actually, I'm not gonna implement the switch statement yet. So this check is done. Let's do the read variable write stack check. Now, since we did the read variable write check already, that's half of the work right there. We just need to also check if, actually, I'm gonna start off by just copying and pasting this code. What else do we need? We also need the argument for both the destination and the size, since this check is looking at both of them. Okay, function to analyze reference size argument. Var node dest equals inputs dest arg plus 1. Also, let me see if I can't scroll up to a... The reason why I have the plus 1, so the first argument I'm calling it 0, indexing it from 0, so the first argument is 0, second argument is 1. However, for the P code itself, the first argument is the function being called, and the rest are the arguments to the function. So that's why you have the plus 1 right there. Now for this, we just need to also throw in a check to see if the destination is a fixed size stack buffer. For that, we already have this cool function called getVar, not getVar, get stack offset. Sorry, get stack var size. So we can just go ahead and call this function. And we know that according to what the function does, it should, if it isn't a stack buffer, return a -1. So we can just do an if stack offset is equal to -1 return. And at this point, if it gets to here, it should actually be a variable write check into a fixed size stack buffer, so we can go ahead and just flag it. So let's go ahead and do that. Read variable write stack check, and let's go ahead and establish the enum for this. Private static final integer. I misspelled integer. Okay, and let's add this. Actually, yeah, let's add this check to read. Okay, it appears that I did not. Okay. It's right. Forgot the K at the end. Okay, that ran just fine. Okay, let's just make sure all of our checks run correctly according to our POCs. This one right here, fixed size constant into a stack buffer, that's overflow. They should get flagged by the fixed size check, which actually, I'm just going to go ahead and go up here where we have all the enums established. This should be flagged by 1, which you see here. That is what's happening. Let's look at read 001. Here it is reading in a constant size into a chunk that is malloc. Even though it is an overflow, none of our rules that we should have, or we have, should flag this, so it shouldn't get flagged by anything. I ran it against read 000, not 001. That was my mistake. Okay, didn't get flagged by anything. That's what we wanted. Let's look at our next test case, read 002. This right here is scanning in a variable amount into a malloc chunk. It should get flagged by the read variable write check. The binary will see it as a variable write since the variable is coming from the arguments to the function, even though the argument being passed is a constant. Flagged 2 is variable write check. That is what we wanted. And let's look at read 003. This is doing a variable write check since it's being passed in as argument into a fixed size stack buffer. This should get flagged by both 2 and 3. Okay, got flagged by 2. Why did it not get flagged by 3? Let's first make sure. Let's see, is it making it down here? I'm going to add a few print statements, that way I can see exactly where in the code, where in the function it's exiting. Okay, let's run it. This should give us some insight into what's going wrong with this function. So I made it to new just through, so it's probably that's what is causing the issue. Stack offset. So the issue is here. Okay. Why is it having that issue? So the issue is with our get stack var size. Why? Let's take a look at get stack var size since that's where the issue is being presented. I'm gonna add a return statement, not return, a print statement here. I think that might be where the issue is. I should also probably print out the var nodes. Actually, what I can do is just go ahead and also print out the P code that is being, oh, that is the, yeah, where the var node is being defined. Actually, I'm gonna try something. I'm gonna try re-importing into a different project. Since right here, this looks like it is getting set equal to the output of a malloc call. I say that because this is the definition of the var node, and it's being set equal to a function that is called with a single argument that is OX6400. And since I wrote if you look at oh my gosh, I'm pretty sure I was running it with the test case read 002, not read 003. Okay, yeah, that was the issue. We see it's flagged by both 2 and 3. Okay, so it's literally just my smooth brain mistake. So we see with the basic POC test cases that we ran, we were able to effectively get the checks done that we wanted to. My next step is I'm going to write a few more test cases that effectively kind of present it with a few other scenarios just to make sure that the checks are functioning the way that I want them to. And then after that, what I'm going to do is I'm going to focus on two different things: writing more checks and also expanding the checks. And let me give you an example what I mean by that to other functions. For fgets, like the function fgets, the checks that I have effectively work the same way as they do for read. So what I can literally do is just take it, copy, and paste it, and fgets, and just change the arguments for the size and the destination. Size here is the second argument, source is the first. And just like that, literally in the 5 seconds it takes me, I was able to apply my checks to fgets as well. And yeah, I'm going to end it for this video. Thank you for watching.